Hello, welcome to ANS Solver. This is the fourth question of the paper. As you can see, we need to integrate 4 sine 2x plus 2 cos square x with the limit 0 and half pi. Okay, before we start this question, if you notice, cos square x cannot be integrated directly. It needs to be converted to a form. Okay, so this is really important, so I'll write it with red. Okay, so for this is basically the cos square x form. Okay, so that we'll convert this into an easier form so that it's easier to integrate. Okay, so now I know a trigo property that suggests cos 2x is equal to 2 cos square x minus 1. Okay, so I can write this as cos 2x plus 1 equals to 2 cos square x. Got it? So now I can write cos square x basically as cos 2x plus 1 over 2. Okay, I can write it something like this. So now I know cos square x is equal to this. So now in this integration question, instead of cos square x, I'll substitute cos 2x plus 1 over 2. So now I can simply cancel the 2 here. Got it? So I can write this basically as, from 0 to half pi 4 sine 2x plus cos 2x plus 1 dx. Okay, this is what I can write. So now the integration of sine 2x. Okay, so for this you need to know the integration of sine, which is minus cos. So I can write this as minus 4 cos 2x over the coefficient of x, which is 2 here. Got it? Plus, now integration of cos 2x. So the integration for cos is simple, sine. So that's sine 2x over the coefficient of x, which is 2. Got it? Plus the integration of 1, which is x, with the limits 0 and half pi. So now what I need to do is first put half pi in the place of x. So it will look something like 4 cos 2 into half pi over 2 plus sine 2 into half pi, okay, over 2 plus pi by 2 minus, this is basically minus 4 cos 0, because 2 into 0 is 0, over 2. And I know when I put 0 in sine and x basically here, I get my answer as 0 only. So now if you go on your calci, make sure you're on the radian mode. If you solve cos of 2 into half pi, okay, just do that on the calci, you get your answer as minus 1. So minus 4 into minus 1, okay, will give me 4. So I'll get 4 by 2 here, plus, now do sine 2 into half pi, which will give you 0, plus pi by 2, minus, if you do minus 4 cos 0, or just do cos 0, so you will get 1. So I get this as minus 4 by 2. Got it? So now 4 by 2 I know is simply 2, plus pi by 2, plus I know 4 by 2 is simply 2. So I can write this as 4 plus pi by 2, which is the final answer of my question. Okay, so I have given the exact value, which is 4 plus pi by 2. Now use a trapezium rule with 2 intervals. Okay, this is important to find the approximation to, okay, now for this you need to know a really important concept, which is called as the trapezium rule, or the area of trapezium. Okay, so the formula here of area of trapezium is basically half into the strip width into the twice of the middles plus the ends. Okay, so what we basically do is think about it step by step. I know my graph, let's say something like this. Let's say my graph is something like this. I've just made a random graph. Okay, my limits are between 2 and 8. So 2 lies somewhere here and 8 lies somewhere here. Got it? So now I need two intervals. Two intervals basically means two gaps. Okay? So now if I want two gaps, that means if I make a line here in the middle, I'll have a gap 1 here and a gap 2 here, correct? So I have made two intervals. But now this line should be the midpoint of 2 and 8. So how do I calculate the midpoint? I know the difference between 2 and 8 is simply 6. That should be divided by the number of intervals, which is 2, which will give me my value as 3. So if I do 2 plus 3, okay, I'll get 2 plus 3 basically as 5. So I know my midpoint is 5. But this 3 suggests my strip width as 3, because strip width basically means the difference between every value. So 5 minus 2 is 3, 8 minus 5 is also 3. Okay, so I've got my strip width now. Now the thing which I need to do is, I know my y is equal to, so all of this is working, which we need to use to substitute in the equation. Okay, now I know my y is equal to root of ln 1 plus x. Okay, now I know my x values are simply 2, 5 and 8. These are my three critical x values. So I'll write this as x equals to 2, x equals to 5 and x equals to 8. I need the respective y values for this. So simply put all these values in the place of x. So when I do this, I basically get root of ln 1 plus 2, which gives me 3. Root of ln 3, correct? Here I get root of ln 5 plus 1, which is root of ln 6. And here basically I get root of ln 9. Correct? This is what I get. So now I need to know these are my ends. Okay? These two are my ends. And this is my middle. Because basic common sense, if my graph is from 2 to 8, 2 and 8 are my ends and 5 is the middle. So now basically we need the y values here. Y values are important. So now if I go back to my formula, I have half into the strip width we calculated, which is 3, into the twice of middles. I know my middle is simply root ln x, root of ln 6, sorry, not ln x. Okay, plus the ends, which is basically root of ln 3 plus the root of ln 9. Okay, this is what I have. So I can simply solve this on the calc. Okay, just I'll take a little bit of time, yeah, because there's a lot to type. Even you all can try till then. See, this concept is fully conceptual. Like, if you don't know anything about the concept, you might be a little blank here, because like this is basically, this comes in integration P2 chapter. Okay, and it's a really important concept, you can say. It's a rare concept. This is not asked much, but it comes, so you need to keep it in mind. So when I solve this, the answer I get is 7.81. Okay, this is what I get.